Okay, John, let's do another question like this. Remember, all we're doing is solving linear equations. So pretend that the cosine theta in this question is really just an x, and just solve for x at the bottom of the equation. Okay, so let's go through and do that. We have cosine theta is equal to 3 cosine theta plus 1. Now, if this was x is equal to 3x plus 1, excuse me, sorry, 3x plus 1, how would we solve this? Well, I'd want to get all of my x terms together. More than likely, I'd want to subtract that x over here just so I could be subtracting, but then everything would be on one side. So I think I'm going to subtract that 3x and bring it over to the other side. That's exactly the same thing that we're doing right here. Cosine theta and 3 cosine theta, they're like terms. They're the same variable. So we just have to combine our like terms. So I'm going to subtract 3 cosine theta from both sides, just like I would have done over there. So I have 1 cosine theta minus 3 of them. That's going to give me a negative 2 cosine theta is equal to 1. Now I'm going to divide both sides by a negative 2. So cosine theta is equal to a negative 1/2. Now, that's fantastic. That's great. In fact, if this was really just an x, that's where we would stop, and that's when we would be done. But that was in Algebra 1, and now you're in Algebra 2, and we have to do more stuff, which is fantastic. So, cosine theta is equal to negative 1/2. Now, let's just take a look up here and read what the directions say. Find all of the values of theta in the interval between 0 and 2 pi, meaning all that means is I want to see every single answer that I could between 0 and 360 degrees. Or I want to know all of the answers in all 4 quadrants. Okay? So this is cosine theta is a negative 1/2, meaning we are going to have 2 answers where cosine is negative. Cosine is positive here, and it's positive here. So we're going to have an answer in the 2nd quadrant, and we're going to have an answer in the 3rd quadrant. Now, it's not a problem, but here's what we have to do. We need to figure out what the answers are in these other quadrants. And in order to do that, we're going to have to use 180 minus theta and 180 plus theta. Okay, but here's the question. What's theta? Well, theta is the reference angle that we find up here. Theta is the answer in the 1st quadrant when cosine theta would be positive. So there's 2 different things that we could do. We could go back and we could look at our reference or our magic table and figure out when cosine theta is a positive 1/2, or you could put it in your calculator. But when you put this in your calculator, put it in as a positive 1/2 because it'll tell you what the theta is. It'll tell you what the reference angle is. Here's what I need you to do. Whenever you have a negative answer like this, so your answer does not include this theta, I want you to make a little note on your paper like this, reference angle. And I'm going to write that the reference angle is 60 degrees. Now I know that from the magic table, which you should probably have out in front of you. So cosine theta is equal to a positive 1/2 when theta is 60 degrees. So 60 degrees is my reference angle. That is not a part of my answer because I'm not looking for the answers that are positive in the 1st quadrant. So I really just use that reference angle to figure out what the other ones are, what my real answers are. So theta is equal to, and I'm going to make my brackets. What's the answer in this quadrant? 180 minus theta, or 180 minus 60, that's 120 degrees. And then 180 plus theta, that's 180 plus 60, so that's 240 degrees. So those are my 2 answers for theta. Okay? Here's the last problem. It's not really a problem, it's not that big of a deal, but because of the fact that our interval for the answers were written as 0 less than or equal to theta less than or equal to 2 pi. Because it says 2 pi right here and not 360 degrees, because it says 2 pi, that means that they want your answers in terms of radians. Ooh, radians. So this interval kind of gives you a clue about how it wants your answers to be. If this said theta is between 0 and 360, this answer would be perfectly fine and you could move on to the next question. But because it says theta is between 0 and 2 pi, I now have to put these answers in terms of radians. So remember that in order to change from degrees to radians, we multiply by pi over 180. So let's see, we have 120 times pi over 180. Remember, you're not going to put the pi symbol into your calculator. You're going to leave that pi symbol in your answer because you want your answer in terms of pi. And then you're just going to do 120 divided by 180 on your calculator. 120 divided by 180, just so that I could reduce that fraction down just a little bit. Hit enter. Math, enter, enter again. 2/3. So your answer for the first one is 2 pi over 3. Now 240 degrees multiplied by pi over 180. You see how all these things that we've learned in the past are all kind of coming together? That's really important. That's actually why I think it's a good idea that you kind of are going through this stuff really late, just so that you have an idea, like you have all this stuff really fresh in your mind because we just did it. So I'm going to leave that pi symbol out. I'm going to do 240 divided by 180, and that gives me, as a reduced fraction, 4/3. 4 pi over 3. Okay? That's supposed to be a 4. That looks like a y to me. Okay. So my final answer, theta is equal to, make a nice bracket, 2 pi over 3 comma 4 pi over 3. Okay? So that's where theta is a solution to the equation above. Alright? So hopefully this stuff isn't that hard for you. It's really just, you know, a linear equation. It just kind of gets a little bit tricky towards the bottom when you actually have to solve for theta. The other thing that I wanted to point out to you in terms of this question is that because this says that theta is less than or equal to 0 and less than or equal to 2 pi, that means that, say one of our answers was 0. Well, you know how 0 and 360 or 2 pi are exactly the same spot on the unit circle? If your answer was 0, you actually have to write 0 and 2 pi, or 0 and 360, because they're in the same spot. Okay? Let's see what we have on the next page. Solve theta to the nearest degree in the interval between 0 and 360 degrees. So, because this says between 0 and 360 degrees, that means that our answers are allowed to be in degree form. Okay? So, this is just a normal linear equation. It just looks confusing because it has sine theta. But this is what it really looks like. And during the test, if you ever get confused about what you're doing, you are completely, you know, I was actually encouraging kids, if you don't really understand what's going on, you could replace the sine or the cosine with just an x if that makes you feel more comfortable with solving this equation. So this is really 5 times x plus 3 is equal to x plus 12. So how would you go about solving an equation like that? Well, I would distribute that 5 through first. So this is really 5 sine theta plus 15 is equal to sine theta plus 12. Now remember, I want to get my sine thetas or my variables all by themselves. So my next step is I'm going to subtract the sine theta over to the left hand side of the equation just so that I could get all my sines together. Alright, so these two cancel out, and I have 4 sine theta plus 15 is equal to 12. I'm going to subtract that 15 from both sides just to move it over. Isolate the variable, get it all by itself. And I have 4 sine theta is equal to a negative 3. And then last step, I'm going to divide by 4. All very easy stuff that I'm sure that you won't have any problem with. The biggest mistake that kids were making on this test was writing down all of the answers. A lot of them just kind of forgot and write down the first answer that they came to instead of figuring out, you know, oh, it's positive, so I have to do it in all these quadrants, or it's negative, so I have to go in all these quadrants. So on your test, stop right here at this point. Sine theta is equal to something. Look at the sign. The sign, the SIGN, is that this is a negative answer. So let's take a look. Let's think about it. Where are my answers going to be in the quadrants? All students take calculus. This is really important, John, that you write it out every single time and circle where your answers are going to be, okay? So this question said solve for theta in the interval between 0 and 360, meaning I could have an answer in all 4 of the quadrants. On your tests, sometimes they'll say between 0 and 180 or 0 and 90. So you have to think about where could my answers possibly be. So I could have them in any 4 of the quadrants for this question. So in which quadrants is sine going to be negative in? Sine is going to be negative in the 3rd and the 4th quadrants. Now, this is another one of those opportunities, chances or whatever, where I'm going to have to do 180 plus theta down here for the 3rd quadrant, and the 4th quadrant I'm going to do 360 minus theta. Now, what's the problem? I have no idea what theta is. Theta is my reference angle up here in the 1st quadrant. Theta will not be in my answer, okay? Theta is up here in the 1st quadrant. Sine is not negative in the 1st quadrant. This is just your reference angle. Write it somewhere by itself. It does not go in your answer, okay? I'm saying this a lot because a lot of kids were messing this up and writing their reference angle in the answer. Okay, I need to know what this reference angle is. So I'm not going to type in second sine of negative 3/4 because that's going to give me an answer somewhere else. I don't even know where it's going to be. It's just going to be weird. So when you're typing in to figure out what a reference angle is, always type in the positive value because sine would be positive in the 1st quadrant. So I'm going to do second sine and then a positive 3/4. That's going to tell me what my answer is up in the 1st quadrant. That's 48.59, or I'm going to call it 48, yeah, we'll call it 59 degrees because we're going to have to round at the end, so I want to have enough decimal places to make sure that I can round. I'm going to stop this right now and then start up on the next video.